Okay, so yes, we have started. Okay, so what we will be starting now is something as shortest path algos, shortest path algorithm. Okay, now at first we will cover something as SSSP, which is nothing but, do anyone know this SSSP? We have learned in college. मनन बोलेगा क्या 2 साल हो गया, कौन याद रखता है?
Salesperson,
हाँ,
shortest path
I know Dijkstra एक ही है ना, और क्या
हाँ
है?
वही.
Dijkstra.
Dijkstra.
So we will learn this. Okay. So the first
नहीं,
category which we,
salesperson.
the first category which we'll learn is SSSP, which is nothing but single source shortest path. Okay. So given a graph to you, okay, given a, obviously a weighted graph, something like this. Okay, we have some numbers. Okay, and given a source, let's say the source is this. Okay, what you have to do is you have to find out the shortest path from this node to all the other nodes. Okay, so given a weighted graph and you are given a source, you need to find the shortest path from that node to all the other nodes. Okay, is the question clear?
Yeah.
Yes.
Right, so this is what we have. Okay, so there is a very famous algorithm to solve this. What is this pronunciation of this? What mana DJ?
Dijkstra. Dijkstra.
डीजे, मैं तो डिजित्रा बोलता हूँ उसको. इसलिए डिजित्रा.
DJ algorithm. So it's Dijkstra.
डीजे.
ठीक है, it's Dijkstra's algorithm.
Dijkstra.
Yeah.
हम्म.
ठीक है. So Dijkstra is a very popular and powerful algorithm which is even used in real life applications also, that you have some kind of network given and you need to find out, कि भाई from ये node to all the other places what's the minimum distance. Okay, think it as a real life problem कि you are here and there are multiple ways to reach someone's home. Okay, there are
Google
multiple ways.
Maps.
Yeah, so each has some kind of cost, let's say whether it's a traffic or something, some other things, right? कुछ भी हो सकता है. So there is a cost given to you, maybe some units of time, and it's a real life problem and you have to reach कि भाई इधर से लेके इधर तक कहाँ तक पहुँचना है. So even I guess Google Maps have a slight variation of this. I mean, they use something as A star probably, but like it can be employed. But the only problem is it has little bit of high complexity. Okay, but anyway, we will see what this is, at least for us. I mean, it's required because uh, this is a very famous algorithm, and in most of the online assessments, in most of the interviews also, and Google asks this a lot. I see. Okay, Dijkstra तो आता ही रहता है. ठीक है, so we need to know how this works. Okay, no. So we have a graph with us. Okay, so I'm just diving into the solution because this is a new for us and there is no kind of intuition whatever. Okay, so what Dijkstra do is, I mean, first the thing which we need to create is something as distance array. Okay, now distance array is something which will tell what's the distance to that node. Okay, so how many nodes we have?
10.
0, 1, 2, 3, 4, 5, 6. Okay, so remember initially what we do, everything is infinite, right? I mean, we have not reached anything, correct? Since we are starting with node 1, obviously we know the distance will be 0, same as BFS stuff. Okay, the only difference between, okay, prior BFS and Dijkstra is Dijkstra uses something as priority queue instead of normal queue. Okay, okay, so one of the question for you guys is, अगर Dijkstra नहीं है, if Dijkstra does not exist, can you solve this problem using BFS?
Yes.
Others, I'll ask you, Manan,
Hmm.
कि how will you solve this using VFS? Yes तो बोल दिए, करना कैसा है?
करना है वही तो सोचना है.
तो
Hmm.
see, can see
Could you just repeat the question, dude?
the question is, if you don't have Dijkstra or if you don't know this
Hmm.
algorithm, if you only know VFS, can you solve this?
Yeah. Priority queue say you'll be like using the lowest
भैया,
thing, right?
let's say that's what Dijkstra uses priority. If you don't have priority queue,
Hmm.
then what?
Max heap, min heap.
अरे भाई, मैं क्या, priority queue is nothing but max heap min heap, no?
Max heap and min heap, yeah.
But then I asked you, if you don't have this kind of power, you have only BFS, you know only BFS, then how you can solve this? Sas,
Okay, okay, we'll find all the
hear me.
paths. He's there, he's there.
Yeah. So we can find the all the paths and find minimum.
The minimum in it.
The first thing I mentioned in BFS is BFS works on uniform weight. Is there uniform weight here?
No.
No.
Then it's impossible, right? Say you have something like this. So from 1 to 3, what is the distance? कौन सा है shortest? Is it better to go this path or this path?
Below path.
Below 1, right? So it should be 4.
Yeah.
If somehow you can model this problem as, now does BFS works? I
Yes.
decomposed everything into ones.
Hmm.
Now will BFS work here?
Mm,
And can we find
yes.
from
Yes.
here to here and here to here or whatever? I mean, from here to here the shortest path?
Hmm.
Yes.
Yes.
Yes, right? But obviously this is doable, but yes, a banana is very hard, right? I mean, like
Correct.
in
There are
diagram,
a lot of nodes.
exactly. So there are a lot of nodes.
Hmm.
So it's kind of not impossible. It's doable, but it's very hard. Okay. And obviously TC just gets passes. Okay. I mean, not passes, I mean it exceeds the limit. Okay. So ये तो नहीं होने वाला. Okay. So that's why there is something as Dijkstra's algorithm. Okay. And for that Dijkstra, we will use something as priority queue. Okay. Priority queue. Now, so what we have initially done is we have started with something as this, right? Something as all infinite, correct? Something as infinite. This is 0 because we are starting from there. Now, we'll take a small graph because it does make sense. ठीक है? Maybe 7, 2, 3, 4, 4. Okay, this is node number 0, node number 1, node number 2, node number 3, node number 4. Okay, now, so let's say we are starting from node 1. Okay, so first thing first, what we will do is we will have something as min heap data structure. Okay, in min heap we will use two things. One is what's the node, one is what's the distance to that node. Since we are at node 1, can I say the distance from node 1 to node 1 is 0? Because since you are at node 1, there is
Yes.
no distance, right?
Yes.
Okay,
Hmm.
we'll pop this up. Okay, we'll pop this up. So this gets deleted. We have something as 1 comma. Same as other algorithms, please go ahead and uh, please visit your neighbors. Okay, so what are the neighbors? The neighbors are something as node 0, node 2 and node 4. Okay, let's start with node 0. Now, from node 1, from node 1, what's the distance you have taken to reach node 1 is 0, right? 0 से लेके with plus 7, can I reach node 0,
Yes.
Yes.
right? Now, what's the distance you have initially? I mean, this will denote the best distance, okay? So, initially, without anything, I am reaching at a distance of infinite, which is a very large value. But can you see I am able to reach with a distance 7?
Yes.
Hmm.
Okay, so please go ahead and update it. As soon as you update this, what you need to do is add that. Okay, so my node number is 0, my weight is 7. Clear?
7.
Idhar tak?
Hmm.
Chalo,
Hmm.
fine.
Yes.
From node 1, can I go to node 4?
Yes.
Yes.
Okay, if I go to node 4, what's the distance?
1.
1.
So initially I was having infinite, but now I am able to reach at,
1.
okay.
Hmm.
uh, Now let's take this is a very some large distance. Okay, let's take. So from 1, can I go to 2? Yes, I can go to 2.
Yes.
So what's the distance? The
Yes.
distance is 0 plus 10, which
10.
is 10. So 10 is better than infinite, obviously. So please go ahead, add it in the priority queue. Okay. Now we are kind of done with. Okay. Now in the maintained priority queue, which one we will pop it up? Node 0, node 4, or node 2? What do you think?
0.
4.
नोट 0, नोट 4 या नोट 2, कौन सा पॉप करेंगे? Which one we will do?
4.
Yes.
For least value is 4.
Yeah. So the least value having weight is 1, right? Which is node 4. So we will pop
Hmm.
this one up. Okay. Now, from 4, so we are at node 4. We reached with a distance 1, right? This is the meaning of this, right? Now, from 4, can I go to 3? From 4, can I go to 3?
Yes.
Yes. So what
Yes.
will be the
Yes.
cost? Total
4.
cost?
4.
1 plus 4, right? Because you have already taken 1, correct?
Yes. Yes. Yes.
So
Yes.
1 plus 4 is 5. So initially I was reaching at a distance infinite, but now I am able to reach at distance 5. So if it is possible, please go ahead, add it to the priority. Okay? Now, from 4, where can I go to?
2.
2. Okay? So if I go to 2, what will be that cost?
5.
5, right? Because I have reached at a distance 1 and it will take more 4 to reach here. Correct?
Hmm.
Now,
Yes.
initially we reached at a distance 10, but now we are
Hmm.
reaching at a distance 5. So is it better? If it
Yes.
is better, please
Yes.
update it and add it.
Add it.
That node number, uh,
2.
node number 2.
Comma 5.
5.
Yeah. From 4, we can also go to 1 also, right? But if we go to 1, the cost will be 2. But we are reaching at a node 1 with a cost 0. So it doesn't make any sense to go with a cost 2 when we have a cost 0, right? ठीक है? So is this
Hmm.
phase clear? ये वाला 4,1 का phase clear?
Yeah.
Okay, nice.
Yes.
Now we have 4 nodes. Which one will be popped out?
2, 5.
Yeah. So now you don't have control. I mean, you maybe 3 comma 5 might also be popped out, but assume that let's say 2 comma 5 popped out, okay? Because 5 and 5 are same, right? So anything can pop it up. Okay? Now from 2 comma 5, what's the meaning of this? You reached node 2 with a distance of 5. Now from 2, where can I go to? I can go to node 1. Okay? So what will
Hmm.
be the distance? The distance will be 5 plus 10
It's 10.
but I am already
Mm.
reaching at a distance 0. So why will I go to distance 15?
Mm.
No way. From 2, I can go to 4 with a distance 4. So 5 plus 4 will be nothing but 9. But I
Mm.
am reaching at a distance 1. Why will I update? Why will I go with a distance 9 when I can reach at a distance 1?
Mm.
Correct? So can I say this is done? 2 5 is done. मतलब इसका कुछ काम
Yes.
हो गया.
Yes.
Right.
Yes.
So
Yes, correct.
next, which one will be popped out?
3 5.
3 5.
3 5.
What's the meaning of this? You are at node 3. You came with a distance 5.
3
अब
5.
देखो 3 से भाई कहाँ कहाँ जा सकते हैं अपन? 3 से
0
0.
and 4.
I can go to node 4. But will I ever go to node 4? No, because it
No.
will
No,
cost me
it's
5 plus
already
4,
still.
which is 9, which is very high since we have already distance 5. Now, from we reached node 5, node 3 at a unit at a cost of 5. Okay. Let's say let's say this is 1. This cost is 1. Now, what will be the distance to reach 0?
6.
6.
6, right? So if it is 6, I was reaching initially node 0 with cost 7. Now I am able to reach with a better distance. So please go ahead
6.
and update it. ठीक है? Clear? Now,
Yes.
Yeah.
can I go anywhere else from 3? I don't think. ठीक है? तो भाई
No.
इसका काम खत्म. Now, this is also been popped out. Now, which one will be popped out now?
0 6.
Uh, 0?
6.
Yeah, so 0 6
Yes.
is the same. So we are at a node 0 and we reached with a distance 6. चलो 0 से
Mm.
देखते हैं कहाँ कहाँ जा सकते हैं. From 0 we can go to 1 with a cost of
1.
13, but obviously we will not
13.
go. From 0
Mm.
we can go with cost 7
7.
with node 3, but node 3 is always I mean
5.
having a distance 5, so
Mm. No use.
no use. So we are done with this. Next, which one will be popped out?
0
0,
7.
4.
Can you see something? Node 0 we are processing it twice,
Twice.
right? But yeah, we'll process it. Nothing, no harm, right? 0 से लेके मैं अभी कितना 7 में पहुंचा. So from 0 if I
7.
go to 1, so with the distance of 14, which is not useful, with the
14.
distance of 8 to 3, obviously not useful. So this is also of no
Done.
use.
Waste.
ठीक है? Now which one?
Only
210.
remaining 10.
210.
210. The meaning of this is you reached at a node 2 with a distance of 10. चलो भाई 2 से देखते हैं. 2 से कहाँ कहाँ जा सकते हैं?
1 4.
But will you go?
1. No, because it will be 20.
Yeah. So
So
20
it is already
and it is 14. So obviously it is not a better one, right?
correct.
Let's say in this graph 5 is alone. Okay, 5 is alone. Okay. Now can I say all my nodes are popped up? Matlab everything is empty now. Can I say priority queue is empty? Because you have processed all
Yes.
the nodes, right? Now see the distance array and tell me, did we get the perfect answer for everyone? From node 1 to reach node 0, I will follow this path 1, 4, 1. Did you see 6? That means we are getting the perfect answer.
Yes.
Yes.
2, it is saying 5. And if you see, we reached at a node distance 5. 1 plus 4. To node 3, we reached at the distance 5. To node, what? Node 4, we reached at a
4.
distance 1.
1.
To node 5, it's infinite. Can you see it's infinite because there is
Correct.
no way to reach from 1 to 5?
Yes.
Yeah.
Yes.
So this is it. I mean, this is your Dijkstra's algorithm. After processing this is the array which you will have at the final, which will tell you that you have the perfect
Perfect.
Perfect
Yes.
from single source shortest path, right? That means you started with one because one is your source node. From that source node, we have found out the shortest distance. And since 5 is kind of unreachable, you have a distance infinite. Okay? Is
Yes.
the thing clear?
Yes, bro.
Yeah.
Yes. Yes.
Two things to note it down. Okay? First thing, what's the TC of this? The TC is nothing but E into number of edges into log V. This is the time complexity. Okay? This is the time complexity. Okay. Second thing is what we were doing here. Can you see node 2 processed? I mean, node 2 got processed multiple times. Node 0, sorry. Node 0 got processed multiple times.
Mm. Yes.
Yes.
So, one thing uh, we can try it, if you don't, I mean, there won't be any problem. But I saw one problem in contest which did not pass because of this kind of situation, that node 0 was processing, I mean, some X node was processing multiple times. Okay. So we will do a small tweak to see how can we pass that kind of code also. Okay. That we will see in the code. The third thing to importantly is which data structure we are using.
Priority.
Stack.
प्रायोरिटी स्टैक कहाँ से आ गया, ये तो प्रायोरिटी
Oh,
क्यू है.
sorry, sorry.
अरे
Yeah.
भाई तुम क्या दिखा. ठीक है,
No, no, sorry.
प्रायोरिटी क्यू. ठीक है. नाउ
Yeah.
इन द ओरिजिनल पेपर ऑफ Dijkstra, the guy who wrote Dijkstra's algorithm, he used something as Fibonacci heap. Okay.
Mm.
ठीक है, it's a binary heap something. So he used something as Fibonacci or something एक रहता, but he did not use priority. I mean, it's a kind of heap. Priority is also a heap data structure, but he used Fibonacci heap something. Okay. So we can read, I mean, if you are interested, you can read this, but what we will be using obviously is priority. Okay. So shall we go and code it up quick, little quick?
Yes.
Yeah.
Q empty arena. Then we are checking the neighbors. And then we
There is
are.
an extension which will help us to share the code. I mean, someone can code it up. So if you say Manan, I will install that extension and you can go ahead and.
Mm.
So what we need,
Adjacency list. Hit start node.
uh,
Dijkstra.
okay. So is our graph created? We have
Yes.
created our graph, right? No. Int,
Start node.
yeah. So start node.
Priority queue.
So int distance array, we will write a separate function which will help us to solve it. Okay. So we will just pass start node and we will print that.
The distance array. No. Distance of 5.
Okay. Static. Okay. I'm just writing the initial things. So do you guys know, right, that this is not a good convention, at least in coding
Yeah,
interviews. You should not
yeah,
Yeah.
because
use this.
mm,
But since I mean, I have. the privilege to do anything right here. So
Mm.
चलो अब क्या बनाना है?
Priority queue.
Priority queue.
Priority queue of what? Node, right?
Node.
Yeah.
Okay. So what we'll write is something else. I don't know whether it will work here or not. In case if it doesn't, we will ask ChatGPT to fix it. But this is how I write. We'll write something as comparator.
Public int compare.
Okay.
Hmm.
Oh, it doesn't work with this. Okay, fine. Let's see. Public.
Okay.
Okay. So okay. So this is something as we defined a priority queue, and you can use something as comparator. अब comparator क्या है मतलब? Can you see now priority queue is having double structure? मतलब we are adding node, right? So
Yeah, yeah.
which
Yeah,
node
node and wait.
you want to pop it up? Okay. So a dot weight
Hmm.
minus b dot weight will give you the node which is having the least weight. I guess we
Okay.
learned
Like,
this in our
yeah,
first.
we have done it. First class, yeah.
Yeah,
Yeah. Custom sorting.
correct. Custom sorting. तो पहले कहाँ से करना है? स्टार्ट से करेंगे, ठीक है?
Hmm.
Hmm.
First we will add it our this one. While
And then we'll check not
Queue is
empty.
not empty.
node
Check the
node
neighbors. Hmm.
Node dot.
I guess you guys are becoming more better than मतलब it's nice to see. अब क्या हो गया इसमें प्रॉब्लम क्या है?
Node में we have two, right? Node dot. We need to go first.
Int not current, it's a current node only, right? Yeah, it's current node,
Yeah.
node
Node
dot
dot.
node.
Node. Okay. Then you go for current node.
Int
Neighbors में.
current weight. Okay, node dot. ठीक है, तो what we have done is we have just separated them. Okay, nothing else. तो opposite में जाओ, ठीक है? Int neighbor node is nothing but what? Neighbor dot node. Neighbor weight क्या है? Okay, is it clear till here?
Yeah, yeah.
Yes.
Okay, अब क्या एक simple check कि if okay, so I kind of forgot to tell you there is this concept of something else, relaxation. Like, what's relaxation? Very simple. You remember we have जब भी हम लोग अपडेट कर रहे थे based on some distance, right? So when I reached here node 4 with a distance 1, when I am going to node 3, what was that? 1 plus 4, right? Correct, 1 plus
Yes.
4. So can I say the weight to reach 4 plus distance from 4 to 3? अच्छा से देखो, weight of 4, that is what is the uh, cost to reach 4 plus distance to 4 comma 3, if it is less than, ठीक है, weight to reach 3, it's always better for me to update, right? Is it making sense?
Yeah.
Others,
Yeah.
मेरे को 4 पहुंचने के लिए 1 लगा, डिस्टेंस ऑफ 4 टू 3 क्या है इधर से लेके इधर तक,
4.
and weight of 3 was infinite something, right? If it was having a larger value and now we are able to reach with a smaller value, why don't you update with a smaller value? That's all. This is known as relaxation. ठीक है, मनन क्लियर है?
Yeah. Huh.
सास इज क्लियर?
Yes, bro.
है?
Yeah.
But why can't we use math.min of
Yeah.
these two values?
Math that mean, no, there can be multiple, right? Multiple matlab you are seeing a single edge, like there is a node, okay, it can reach from here something like this, I mean, there can be multiple paths for this reaching to this node, and we are not sure which one will give this. Okay, so obviously we will use min only, but what I am saying is, let's say this has reached at a cost 9, this is reached at a cost 10 and cost 9. You will update with cost 9, right, first, and let's say
Hmm.
it's going with cost 5, so you will update with 5. Then let's say something has came up with 2, then you will update with 2. So you reached earlier at 5, but now you're reaching at a distance 2, so that's the reason, go ahead and update it. Okay, we are doing internally as a min only, but what we are doing is, this concept is known as relaxation. Clear? Hello?
Yes.
Yeah.
No.
Yeah. Got it, bro.
Okay, so now what we are checking, if my distance of neighbor node, if it is greater than, अच्छा से देखो, current weight, can I say this, current weight मतलब the cost to reach to this node. ठीक है, the cost
Hmm.
to reach to this node, and is it clear, if the distance
Yeah.
is more than current cost plus the neighbor weight is nothing but ये वाला edge, where it is, this one, current cost is this, neighbor cost is this, neighbor weight. Okay, if that is the case, Manan, are you following or not?
हाँ लैग है आई डोंट नो मेरे साइड बहुत लैग है
Yeah, simply update.
We'll update.
Hmm. Curated.
Okay, so what we need to do,
The node and
Neighbor node,
current distance.
distance of neighbor node. Yeah.
Yeah.
we'll return the distance at the end, and this is it, that's all, I mean nothing else. Okay, so what we did, जब तक empty नहीं है निकालो, go to adjacent neighbors, if someone is doing at a better cost, update it, add it to the priority queue. That's all. Clear? They were clear?
Yeah.
या
Shall we run?
Yes, bro.
Yeah.
वही graph लेते हैं, whichever we have taken an input. How many nodes? 1 2 3 4 5 6 nodes, right?
Hmm.
So there are 6 nodes. How many edges?
5.
2 3 4
Also 6. Yeah.
and we have to enter each as a cost. Okay, so 0 से 1 is 7, 1 से 2 is 10.
Yeah.
So remember, 0 से 1 is 7,
7.
Mhm.
1 से
2 is
2 is 10.
10.
now
1 to 4 is 1.
0 to 3 is 1. Wait, this is 1 or
Yeah, 1 1. We have updated.
1.
okay,
3 to 4.
okay, 0 to 3 is 1, yeah.
3 to 4 is 4.
Mm.
4 is
4
4 to 2 is 2.
4 and 2.
4
4 to
4.
1 is 4, right?
Yeah.
4
Starting node
0.
1
Okay, 1. Hmm.
Nice.
60551. 6,
Nice, bro.
Yeah.
crazy nice
right? So very very important and powerful algorithm in the real life also. Okay.
yeah
Hmm.
Okay. So did you understand what happened?
yes
It's very, I mean, it's easy to write. Okay. So the problem which I was telling is the one which I faced TLE, even though I wrote this code, okay, there was a single node can be processed multiple times. Although this for loop won't work, right? This for loop will never work because if you're popping out node 0 with a distance 3, and if you're popping that node after at a distance 5, then will 5 will affect anything? No, right? Because 3 would have already affected that. Correct? True?
Yeah.
Does it make sense? So what we do is we do a little bit of tweak, that we create a boolean array. If visited of, that's all. ठीक है? नहीं तो this is what you have to do. A simple liner, single line, that if it is already visited, don't again go ahead and do anything. Okay? Because when you when you popped out node 0 first time, you have iterated and you have done change. But when you are popping out 0 at a second time, which is having a higher distance, this will be true, right? And if this is true, continue. That means you will not ever go to this for loop. Correct? So I will tell you why it was giving TLE also. Okay? So let's say if there is a graph something like this. Okay? ये वाला node update, let's say this node has how many edges? So many edges, right? So in our priority queue, this node number X would have inserted many times, so many times. So whenever you will pop it for the first time, you will always get the better instance. But whenever you're popping it for the further times, you will again iterate on all the edges, right, in the for loop. Did you see this? Right? If you will always iterate on the for loop, even though this will never occur, but this for loop is something which is costly. So that's the reason you use a simple visited array technique, that if it is already been processed, please don't process it again. That's all. Clear? Clear?
Hmm.
Yeah. Yes.
Okay.
Yeah, yeah.
चलो ठीक है. So this is your Dijkstra. Okay, and Dijkstra इतना ही है, मतलब now it's all about solving the problems using Dijkstra. ठीक है? Then there are tweaks. That's all. Okay. So
Hmm.
remember, Eva, I don't know. I mean, we have done one contest long back. We have used some one more parameter also, cost one, cost two, something like that. Okay, I'll keep that question in the group. I mean, in the sheet. But yeah,
Yeah.
so this is it. So the only thing you have to add it on the top is how you modify, or not modify. I mean, what are the constraints or what are the restrictions you have? You just add it to this node data structure. Okay, that's all.
Hmm.
But this is the pure Dijkstra.